on this infrastructure and with this positioning system and start to get a look at the type of location-based services. And not only the issues of usability and privacy and authentication, but actually content. Because I think one of the things that I wanted to ask the first speaker was, or one of the speakers was not so much the privacy issues about location-based servers, but what about the content and who is liable for the correctness of the data? Do you send an ambulance up a wrong street? This could have catastrophic significance, not only for the person for whom that ambulance was intended, but also the content provider, the location-based service vendor. And therefore you do have, in a sense, obligations on the part of the location-based service providers as well. And I think that's also a fascinating topic. Let's not only point the bone at the location-based service providers. There are many other constraints to that value chain. So let's have a look at sort of something that we wanted to look at, the room-level positioning accuracy. And really, we have a number of technologies, as other speakers have referred to. Of course, GPS is widely used. It's an amazing system. It can give you better than 10 metres accuracy, but it does not work indoors. And I think we have to appreciate the different environments in which positioning can take place. And the first thing that we can divide is between where GPS works and where GPS doesn't work. Because really GPS is an amazing technology that is more and more embedded in our mobile devices. And even though we may have less than 20% of the smartphones or the mobile phones having a GPS capability, the one thing you can count on is that that'll creep up quite rapidly towards the end of the decade. But we've got the issue that the world doesn't work everywhere, and it'll never work everywhere, despite what the claims of some of the manufacturers may be. Alternatives are using the actual mobile phone itself, using the cell phone network, but it's a comparatively low accuracy technology, despite what people might tell you about directional antennas and signal strength algorithms. We mustn't believe everything we see on NCIS or in James Bond movies. This stuff is really, really crude. And the non-line of sight errors, particularly in urban environments, are really deadly and really kill any attempts to improve that accuracy. Now we turn to some of the more proximity-based sensors, in the sense that they deal with a zone of coverage which is now quite small, and if your granularity now goes up, I'm not sure if that's expressed the right way, the resolution goes up because you can pack them closer together. And the example of the Google mapping is one where you can drive down streets and find literally dozens of access points overlapping each other. And it's the fact that they overlap that provides you with a lot more than just the clumsy cell ID concept, where you are within a zone or you're not within a zone, and therefore you're in another zone. You got this, the algorithms are quite different. And really it's the access points that make Wi-Fi attractive, together with the wide range of mobile devices and technologies that have built-in Wi-Fi, like my mobile phone, like my laptop. And universities are therefore an ideal location where one would find many of these access points and many of these devices, and potentially, of course, a community of users. So we'll look at the University of New South Wales. The coverage, of course, is across the campus and indoors, and you don't have to be a registered user of the network. Like here, I can't access email here via the network here, but I can access the MAC address. And really that's what's important. It's a little bit like people's ID. They're talking about the ID number. That's the way in which these networks can be accessed. Now, the one we're going to talk about, Wi-Fi positioning, is an auto-positioning system. It's related to the person. It's not a network-based system. It's therefore not a surveillance system unless you have a way of sending that information from your mobile device to a centre. So when we look at Wi-Fi positioning techniques, the usual suspects come up, and this would hold true also if you wanted Bluetooth or Zigbee or WiMAX or Any RF technology, you can, at the simplest level, you can deal with it as a cell ID positioning technology. That is, are you within range or not? And the range could be, for some technologies, of the order of kilometres if you have a large cell for a mobile phone, whereas with Wi-Fi we're talking about between 50 and 100 metres sized cells, and therefore that is sort of the crudest level of accuracy that you could get. That is, are you in the range of that access point or are you not? But of course you now need a mapping of those access points and also a position for those access points to allow you to then trigger all of the other components of a location-based service. There are other attempts to do triangulation and trilateration, but they are put there really just for completeness. They're like textbook examples of which none of them are really commercially viable. But it's really the fingerprinting technique that is the one that is pioneered by several commercial providers, and probably the one upon which the Google system will be based, because it does have some significant advantages. Okay, cell ID, just for completeness, showing you here. If you have a dense network of access points, you can track people moving from one to the other, just as you would from one RFID reader to the other, or one Bluetooth access point to the other. It's a no-brainer. It's a very simplistic system, and it's all about coverage. So you're needing a technology, readers, access points that are placed there in sufficient density, not for location, but really for short-range communications. We'll just bypass these and we'll go to the one that we implemented, which is basically fingerprinting. That is, each location, and you can imagine this as a grid of location, a grid of latitude and longitude, or any other type of arbitrary grid in a sort of horizontal sense, where at each grid point you can sense or receive signals from a number of access points, a unique set of access points with associated signal strengths. Now that is the basic premise of fingerprinting. It's like your fingerprints, right? At each location there is a different signal strength fingerprinting. It's a little more complex than that because unfortunately we have a dynamic RF environment, and these fingerprints would actually change with the time of day and also with the amount of traffic, human and otherwise. So it's far from a foolproof system, but certainly at a first order approximation this is appropriate. It's like Google. Google will only go up the road. It won't be able to go into your backyard to pick up the other types of fingerprints. So we can be concerned, if you are concerned about Google's fingerprints, but it's only in the front streets. It doesn't really get the mix of signal strengths and access points that one has in a sort of a two-dimensional sense. So basically you get a signal strength and a MAC address, and that's really what you need. And if you can survey that and create a database, which is what Google has done, then by providing that data to that database or accessing data from that database, and this is where the surveillance part comes in, once you connect to the database, there's no reason why that database can not, of course, find out who you are. And because it's providing you with the location, it can then also use that location itself, or at least record that location for other purposes. But we won't go there. So each fingerprint, it's tagged with a location, it's saved in a database, so there is therefore that component of the survey. You have to pre-survey an area at an appropriate density so that when you go back to that area with another device or another person comes into that area, senses the same signal strengths to those access points, then the database can be interrogated, and the most likely position, if you imagine on a grid or along a street, can then be extracted. So fingerprinting does require access to a database. So the user's device queries the database, and the best matched fingerprints position will be the estimated location of the user. And there are a number of approaches to that, but all of them really will have inaccuracies, and that's really part of the issue that we're dealing with here. If we look at it at a strictly deterministic perspective and imagine everything was static, this is a scary scenario, because basically it's like you are, it's like you are, tripping across a mesh, and, each footprint would reveal where you've been on basis of the signal strength. But the inaccuracies are such that, in fact, it's not as nightmarish as that may imply. What is useful about this is that we actually don't need the Wi-Fi access point coordinates. Only the database needs those. It's not affected by static objects nor line of sight errors, because we're not actually deriving distance. What we're looking at is signal strengths, and the signal strengths themselves could be distorted by the buildings, the intervening buildings, and so on. So it's not about measuring distance, it's about if that environment is already distorted, then that is taken into account in the fingerprints. So you do require a grid survey of signal strengths, and obviously updated in the event of major environmental changes. Where it might get scary in the future, and here I'm digressing a bit from this project, is that all of the users who then use this system, if they now sense the new positioning, the new signal strengths, and you start sort of taking advantage of the power of the crowd, then you can create an automatic feedback process by which you can improve the database. Now, I think we're a long way from that so far. So let's look at this particular system. We wanted to look at Roman building search. We needed to be able to sort of at least implement a very simple location-based service that used a map. We wanted to work indoors, and a simple one could be, a search friend type application, or in a sense, at the university campus, we can also look in terms of being able to identify classrooms and relate that to timetables. So I guess that's the sort of the benign application that one could imagine in a campus. Students get lost all the time, lectures get rescheduled all the time, and it would be useful to be able to provide such a location-based service that is applicable for Wi-Fi rich environments such as the university. So the system components with the server where the database is and the client, two types of clients, one being the surveyor, one being the navigator. The surveyor is the one that carries out the initial survey. You may want to repeat that, or you just treat that as your first and only database system, a database generating system. The navigator is, of course, any client that is going to be wanting to access using the WiPOS, using the Wi-Fi system to determine its location and then trigger an application. So in this case here, the server had the database which had the room and building information for the university. It also had the Wi-Fi access points fingerprints. The application was basically executing the positioning algorithms, which would search that database and find the best match, and obviously handles the communication with the client. Now that may of course include such things as making sure that you know who the client was, whether there was an authentication process required, student number, and also because there are security concerns at universities about letting people know what's behind every locked door. And this is one of the things that we learned was how security related to buildings and rooms is handled, or perhaps not handled, on a university basis. The types of clients, we looked at devices. Obviously we had to have maps both of indoors and outdoors, and some way in which we could provide additional information about points of interest, POIs, not just the rooms, but also, of course, disability access, shops, ATMs, the usual suspects, as they say, in this business. The mapping engine and the search features, and we ran it on, were also incorporated within this. Remember, this was a student exercise, so it dealt with, therefore, mobile device programming, Java level programming, some communications requirements, and dealing with operating systems. And in this particular case, we used an Android phone and accessed its features so that we could access, for example, the Wi-Fi strengths. And if it had a GPS built in, we could access the GPS coordinates as well, which obviously this is a hybrid system, but at the moment we just implemented it only for the Wi-Fi. Survey architect, I think we don't need to deal with it, but let's just go to the results because I don't want to take too much of your time. Basic accuracy results, we wanted to be able to differentiate the building level. I mean, this is the most important thing in multi-storey applications, is that many of these indoor positioning technologies signals can pass through roofs, not just through walls, and therefore trying to locate people on the appropriate level can be a challenge. And so we wanted to do some basic accuracy tests to differentiate levels as well as rooms, and also to try to do at least some rudimentary testing on changed environments. That is when people are there and or absent. So this is the test, it's basically just step-by-step process. The methodology is explained in the paper. The find function is really the client navigator. You press find and it will then communicate with the server, send the signal strengths that it detects, and sends you back that information via either a room number or a point on a map. And really by doing this multiple times in different environments, day and night, when students are about or when it's empty, one could build up a sort of set of results that we could analyse. Certainly we found that we could differentiate the level 100% of the time. Within that level, we did this in 2 or 3 of the buildings, but stairwells of course are problematic because you've got signal leakage through the stairwell, so not a good place to try this out when you're on the stairwell. Accuracy tests, we had several different types of rooms, lecture theatres, tutorial rooms, and again trying to repeat this a number of times, different times of the day, inside, outside, next to the room, and try to therefore, in a sense, determine the parameters. This is not very scientific, but certainly we got the accuracy results of something like identifying the correct room, if you were in that room, 46% of the time, but close to 100% of the time if you wanted to be within one room of the correct room. So as a location-based service, it therefore failed to give you the room level positioning, but certainly would give you within one room of where you were. Changing environment, obviously this is now related to the time of day. And the principal variable here is the number of students, because their bodies actually impede the signal propagation, and therefore the signal strengths would be fluctuating quite wildly. So again, looking at running the same tests inside and outside of rooms, and looking at the accuracy not in terms of meters of accuracy or error, but in terms of whether you could identify the correct room or not. Then during class hours, when there were many students around, we could get 47% of the time in the correct room, 87% of the time within one room, that is within that correct room or the neighbouring room. During rush hour, the accuracy went down, and as to be expected. You can see the figures there. And in the quietest period, the accuracy went up, at least the accuracy when it came to being in the correct room or not, or the neighbouring room. So this gives you a sort of a feel for the reliability given these rather crude tests. So the conclusions, we built an early prototype, uses the Wi-Fi fingerprinting technique. We're not using Skyhook or Ekaha, it's just our own system. Provides a level of accuracy sufficient to position a client device within a room or the neighbouring room most of the time, and for that reason it's estimated to be approximately 5 to 10 metres accuracy. Some of the future goals, again, as a student project, ideal final year undergraduate thesis type project. You can allow users to contribute to the system. We can do some crowdsourcing. We can have more accurate algorithms. We can integrate with other positioning technologies. And there are a number of challenges that we've identified that we could try to improve on. We do have but we can't access the YouTube video, unfortunately, but there is a YouTube video that shows the student walking around and with a split screen showing the map on the client device, and reasonably impressive results showing the, if you like, the red dot moving with the student, moving in concert with that student. So thank you very much for your attention, and I'm happy to answer any questions.
Chris, I know it's not exactly on the paper, but the Google Wi-Fi activities, which have come to light recently, appear to have something to do with an intention to create an improved positioning mechanism for Google. We've been trying, quite a lot of us have been trying to work out the extent to which the stories that have been put about are realistic ones. That is from an engineering perspective. Now we've got an environment in which a car is driving along a street. We'll think suburban streets and leave the CBD out of this. It's at 30 kilometres an hour and it's 25 metres to the nearest access point. What, from this research and more generally, do you perceive to be the reality of this? Is it tenable based on this kind of data?
No, frankly, I believe that the best you're going to get out of that is literally a cell ID type system. At that speed, and given that you're only going to be accessing the street, the signals that you can receive in the street, and if you imagine every second house has got a Wi-Fi access point, you can do the maths. I mean, it's like 30, 40 minutes, but for many applications, that's pretty good. In fact, we've done tests in the CBD, and in a 500 metres by 500 metre area, there's something like 2,000 access points. But surprisingly, the accuracy was worse in that environment because so many of these access points come up and down during the day. There's so much traffic that, in fact, it's far lousier than the indoor positioning. So the outdoor positioning using Wi-Fi, I think, is more problematic. But where you've got nothing else, it's a lot better than cell ID. Now, you've got to think about the alternative in a suburban area is 500 to a couple of thousand metres using the cell sort of diameters. Okay, in Japan and with 4G you've got smaller size cells which can bring that resolution up significantly. Getting to within 50 metres of the correct position is already pretty good. And whether it'll identify the house, and you know, I really doubt it. But it does just add another technology for positioning, which at the moment Skyhook doesn't have as good a... See, the whole thing was the complexity of collecting that data in the first place. Commercial companies such as Skyhook were based on sort of people providing that data on a random basis. What Google does is much more systematic. It doesn't mean they have a better technology, but they're collecting the data in a much more systematic way.
The suspicion was, of course, that the real purpose was to collect license providers. Therefore, it's really quite important to work out whether they have extended market. You're saying in terms of...
Yeah. You can always second guess Google. They won't tell you. So...
it's not exactly related to what we're talking about, but we probably know the answer, hopefully. Before I came here, I accessed on my personal computer, the Google search, the Australian Science Media Centre. It came up with a list of all of the items under the Australian Science Media Centre, but at the beginning of that list, it said you have 4 items on your email system that relate to the Australian Science Media Centre. This is coming up on the Google website. I then clicked on those that actually listed the 4 emails which related to the Australian Science Media Centre. Clicked on them, and they had all my personal correspondence between Dr. Binghao and myself about that subject matter. Now, I'm just wondering if anybody knows whether that's an invasion of privacy by Google or whether that's something on my computer which is actually triggering an interaction between emails that I've actually done.
I don't know about that specific example, but I think you'll be seeing more and more of this data mining based on the geo, using position information from whatever source, and no matter how crude it is, cross-correlating that with a lot of other information, your profile, where you've been, what clubs you belong to, what emails you get. I think this is something that's going to happen because a number of these technologies are starting to join up. I mean, you don't collect location information because you want to know where people are. It's what you then do with that, and that's a totally different topic that I'm not an expert on.